In this video we are going to discuss about Heron's formula for computing the area of triangle alpha, beta, gamma. So in one previous video I have showed a computational example using the Heron's formula in order to compute the area of a triangle. You can go back to my videos and spot the video that I have produced using the Heron's formula to compute the area of a triangle. Now I'm going to provide the proof. So as a reminder, the formula for computing the area of this triangle is the square root of tau times tau minus a times tau minus beta times tau minus gamma. This can be rewritten doing some trivial calculations as the product of this one. So it's 1 over 4 times the square root of 2 times a squared times b squared plus b squared plus gamma squared plus a squared times gamma squared, we close bracket, minus a to the fourth power minus beta to the fourth power minus gamma to the fourth power, where this alpha, beta and gamma are the lengths of the sides of the triangle, and tau is the semi-perimeter, which is alpha plus beta plus gamma over 2. You can see this from this sketch over there where I have drawn the triangle. So what we do, first of all, let's draw the triangle. So we have this triangle. Let's take from the spot A, we draw a vertical line. So we have E1 and E2. We have split the triangle into two smaller triangles. For this proof we are going to use the Pythagoras theorem. So let's denote, of course, this is the length A, this is the length B, beta, and this is the length gamma. Now let's write alpha in the following way. So alpha is L1 plus L2. This height over there is called M. So we have let's denote this this point as delta. So we have Pythagoras theorem. In the triangle A, so the hypotenuse is gamma squared is equal to the sum of lambda 1 squared plus m squared. This is the Pythagoras theorem in this triangle AB delta. Now we impose the Pythagoras theorem in the triangle alpha, delta, gamma. So we have that beta squared is equal to lambda 2 squared plus m squared. So we have these two relations, gamma squared equals lambda 1 squared plus mu squared, and beta squared is equal to lambda 2 squared plus mu squared. We solve with respect to m squared, which is gamma squared minus L1 squared. And of course from the other relation we obtain that mu squared, m squared is equal to beta squared minus L2 squared. So from this we have that gamma squared minus L1 squared is equal to beta 2 minus L2 squared. We have this relation. and we can use this relation to find the expressions for L1 and L2. So L2 is A minus L1, and we substitute this. So we obtain that gamma minus L1 squared is equal to beta squared minus A minus lambda L1 squared. So this is gamma squared minus L1 squared. So we do some calculations. Of course, now we can get rid of this L1 squared terms over here. So we have that 2 times A times L1 is equal to gamma squared plus alpha squared minus beta squared. We have this relation over here. Consequently, L1 is equal to gamma squared plus alpha squared minus beta squared over 2A. We have obtained the formula. Now we can find what is the expression for L2. So L2 is, so we have that L1 plus L2 is equal to A. So L2 is equal to A minus L1. So this is A minus L1. This is A minus L1 is gamma squared plus alpha squared minus beta squared over 2 times A. This is 2 times A minus gamma squared plus alpha squared minus beta squared over 2A. So we have 2A, sorry, this is 2A squared. We have common denominator 2A, and this is 2 times A squared minus gamma squared plus alpha squared minus beta squared, and we close the bracket. So we have 2 times A squared minus gamma squared minus A squared plus beta squared over 2A. And this is equal to alpha squared plus beta squared minus gamma squared over 2 times A. Over 2 times A. Okay, now we need to calculate. So we go back to one of the relations here and we can find what is this m squared. So we will use this relation m squared so m squared is equal to gamma, let's use the gamma squared minus L1 squared. So this would be gamma squared minus L1 squared, which is gamma squared plus alpha squared minus beta squared over 2 times A, and this goes to the power of 2. So this is gamma squared minus gamma squared plus A squared minus beta squared. We use the properties there over 4 times A squared. So this is This can be written as 4a squared gamma squared minus gamma squared plus a squared minus b squared, this to the power of 2 over 4 times a squared. This identity, of course, this gamma squared plus a squared minus beta squared is just gamma squared plus a squared minus beta squared squared. So this is, we use the known identity, this quantity squared minus 2 times the product of this quantity plus beta squared squared. So this is, we just do some calculations there, plus beta to the power of 4. So this is gamma to the power of 4 plus 2a squared gamma squared plus a to the power of 4 minus 2 times gamma squared beta squared minus 2 times a squared beta squared plus beta to the power of 4. So this is let's take the higher powers together. So let's take alpha to the power of 4 plus beta to the power of 4 plus gamma to the power of 4. So we take these terms first, and we have plus 2 times a squared gamma squared minus 2 times gamma squared beta squared minus 2 times a squared beta squared. Now let's go back and find what is the expression m squared. So this is 4 times a squared gamma squared minus this quantity over here and this is over 4a squared. We just have to do some computations there. Minus a to the power of 4 minus beta to the power of 4 minus gamma to the power of 4 minus 2a squared gamma squared plus 2 gamma squared beta squared plus 2a squared b squared over 4 times a squared. So this can be written as, we can write, so we can take this term and this term. So it's 2 times a squared gamma squared plus 2 times gamma squared beta squared plus 2 times alpha squared beta squared minus a to the power of 4 minus b to the power of 4 minus gamma to the power of 4, and this goes over 4a squared. Of course, the whole area of the triangle is epsilon 1 plus epsilon 2. So epsilon squared should be epsilon 1 squared plus 2 epsilon 1 epsilon 2 plus epsilon 2 squared. So this is the area of the triangle alpha beta delta is 1 over 2 times the height times the base, which is L1, plus, and this is squared, plus 2 times the area of epsilon 1 and times epsilon 2. So it's m times L1 over 2 times m times L2 over 2 plus 1 over 2 times m L2 squared. So this is 1 over 4 m squared L1 squared plus 2 times m squared L1 L2 over 4 plus 1 over 4 m squared L2 squared. So we take m2 m squared as a common factor, and we have L1 squared over 4 plus 2 times L1 L2 over 4 plus L2 squared over 4. So this is m squared times this is L1 plus L2 over 2 squared. So this is m squared over 4 times L1 plus L2 squared. So epsilon squared is m squared over 4 L1 plus L2 squared. So this can be written as the m squared is given by this relation. Yeah, so it's so the so this can be written as m squared over 4 times L1 plus L2. What is L1 plus L2? So let's do this calculation on the side. Gamma squared plus a squared minus b squared over 2 times a plus the L2 a squared plus beta squared minus gamma squared over 2a, which is this term and this term cancel out because they have opposite signs. This term with this term cancel out, so we have 2 times a squared over 2a. So is we cancel out the 2's, so we just have a squared here. So let's continue. Epsilon squared is 1 over 4 times m squared a squared, which is 1 over 4 times m squared is this relation 2 times alpha squared gamma squared plus 2 times gamma squared beta squared plus 2 times a squared beta squared minus a to the power of 4 minus beta to the power of 4 minus gamma to the power of 4. And this goes over 4 a squared times a squared. This is 1 over 16 times 2 times a squared gamma squared plus gamma squared beta squared plus alpha squared beta squared minus a to the power of 4 minus beta to the power of 4 minus gamma to the power of 4. So we take the square root of this quantity, so it's 1 over 4 times square root 2 times a squared gamma squared plus gamma squared beta squared plus alpha squared beta squared minus a to the power of 4 minus beta to the power of 4 minus gamma to the power of 4. and this can be written as, so how can we write this expression? We have a close look here and we see that we can write it. Finally we obtain the Heron's formula. So this one can be written as the square root of tau times tau minus a, tau minus beta times tau minus gamma. And we have concluded the proof. I hope that you find this video well explained. If you have any questions, please let me know. I know this is a pretty long video, but there are many calculations that have to be taken care of, and when you do this kind of calculations you have to be extremely careful.